Okay, so well, maybe we can start, and the rest of the people will join when it's started. So first of all, let me present myself. My name is Eric Martin. I'm the Artificial Intelligence Director at MDW. And well, I've been dedicated to AI more than 7 years, I think, and also doing artificial intelligence on the cloud and putting things into production, which is one differential step now from the notebooks, the pure notebooks, to things into production. Um, yeah, first of all, let me to introduce very quick our company. So we are an international company with 3 offices. Our headquarters is on Geneva, and then we have the Madrid office and the France office. So some facts about MDW is that we were the partner of the year in analytics and AI, covering 100% of our activity, and we were the first partner in the whole EMEA region in validate both advanced specialization in analytics and data platform. Our customers, well, as you can see here, and this is also a goal of this webinar, we're working currently with different sectors and industries, and the solution that we will see today, it's well, it's focused on an insurance company, but it's something that you can extrapolate to some other business, some other industries, as we will see later. So we are not that much today, so I hope you any question you have, please write it on the chat, and we will go deeper into that. So feel free to ask at any time. So about what we do in MDW is really simple because we are in a double niche. The first one we see it on the last slide is that we only work with Microsoft technologies, and then our second niche is that we are currently dedicated to just one thing: data. And inside this data, we can see it in these three different legs. So the first one is big data, where basically we do everything. So data streaming, modern cloud and data warehouse and data lake, data governance, everything. So well, also one thing that differentiates us in this field is that we are currently working with big companies. So really big data, I would say. And then we have let me skip this one. Oh, sorry, that is the last one because it's the related to the webinar today. Then we have this data-driven application where we can find, of course, business intelligence, where again, we are working with big companies. So we know how to create, let's say, reports, not just for one single customer, but for lots of markets, and also this new part that we are creating right now, that is the business process automation and low-code solution, where we are finding lots of traction on the market. And finally, we have the artificial intelligence part, which is the one that we will see today. So in that part, we are dedicated mainly to something that is really different from what other companies do, that is create end-to-end AI solutions. So meaning that, for example, the one that we are going to see today is from the starting till the end. So ending with something that is useful for the users, even if it's not technical, like the case of today. And well, inside of artificial intelligence, what we do? Well, we do mostly everything. We can handle images, we can handle tests, we can work with unstructured information, as we will see today. We can apply machine learning, let's say traditional machine learning, to tabular data. We can create deep learning models to work with, for example, images and so on. So Thank you and welcome to the webinar. Now I'm focused on the webinar. So what is the objective of today? Well, if I have to say one, I think is this first one. Let me take the laser. So how to extract value from unstructured documents. So normally, what we understand by unstructured documents, we understand like images, for example, PDFs, GPG. So normally, and for some companies, this is nothing. I mean, you have a hard disk with all this information, but you can extract real value from that. So if I have to say what is the goal of today is at least have an idea of how to extract information from this unstructured document that of course has some value and some information. And well, second goal of today is to understand how AI can help us to treat these documents and to get some more advanced insight. So two parts that I will explain later. So first of all is how to treat these documents, and second one is how to, let's say, apply AI to obtain more advanced information. So why do we need this webinar? Is I think when you need it is when your company has this kind of documents and can extract real value from those. And of course, if you want to understand how an AI project, and this is really a very complex AI project because, well, it has a lot of models, as we'll see later, and how to, let's say, to create this end-to-end AI project, and how to create real solutions, because this is a project into production for a non-technical user. This is sometimes a hard step to fix, let's say, and yeah, based on cloud technologies. And here is the thing that is really disruptive, I think, and it is what industries can be helped by a solution like this. And I think it's mostly every industry, every company, because this is actually a problem that most companies has. And I would like to show you some numbers. This is not mine. This is extracted by Microsoft. So before starting, just to comment that, well, the number of bytes created of data created by day is huge, and probably as this is from 1 year and a half ago, something like this, we will be close to 3 here. And here we started to see something, that the 80% of this huge number is unstructured information. And then, and this is, well, this is also an interesting number, is the money lost per knowledge worker in due to information searches. So imagine that you need to check one invoice and you have to open this hard disk, you have to look for this invoice, and this is something important, I think. So, well, with these numbers in mind, we'll try to mitigate and to solve a little bit this issue. The agenda for today is first to define a little bit the goals, the context and challenge that we will face. Then we'll see the solution to the main challenge. Then we'll see an overview of the whole solution. Then we'll see a demo. Of course, I can't show the real demo, but will show you some parts, and I hope you understand it, and then the results and next steps. So first of all, this is a real case. Like I said, it's focused on an insurance company, and I will probably, because it's impossible for me to do it in other way, to talk about document, sorry, to talk about invoices. But please, I will show you now how to extrapolate and how to make it from your own business. So, well, the case is that this insurance company has receiving lots of invoices, as you can imagine, from garage, from house, from other, from lot of sources, and these images, these invoices were in PDF format, in image format, and they were not able, due to the amount of invoices, because it was huge. It was something like 50K invoices per year. They were not able to check one by one and to see if there were any error on these invoices. So, of course, they know, because even by probability is something that can happen, that it will be anomalies on these invoices, and they would like to recover or to talk with the emissor and say, okay, this one is a concept that you have not to pay, not to try to charge us. And what is the extrapolation of this project? So any kind of unstructured document, it hasn't to be invoices. For example, we did mostly the same project without the anomalies part for a trading company that wants to read contracts about crude oil, for example, and to, let's say in a 30-page contract is just important one table, and they want to automatically detect this one table because it's something that really takes the time of their employees. And also to find anomalies into a text. So basically, when you have extract the information present on the invoice, you can try to apply AI to see if this content where you are charging for it's an anomaly. Oh, some numbers here. So more than 200K documents processed with a rate greater than 99%. And what means the rate greater? Means that when we applied the whole process, just 1% were not possible to index, let's say. And detect anomalies into invoices, more than 2 million of CHF recovered using this tool. So a huge number. So more generalistic talking, it's a knowledge mining project. This way to, let's say, to understand and to pass from unstructured documents to structured documents, work the capabilities of search inside, and we'll see later how we're doing this one. And also well, a most common NLP project to understand if a text has an anomaly or not. The goals, I think it's easy to understand, and normally I like to do that, to do that exercise of trying to put the question that you can't answer without this project, let's say. So imagine that, for example, to this company, you ask, okay, what are the invoices from the last month that has anomalies of more than 600 CHF in the last month? And they can't, they couldn't answer you because they don't have anything to read the information. They don't have anything. So basically, with this question, you are showing the real capabilities of this project. But then, like I said, try to extrapolate to your own business. So, for example, what are the documents regarding GDPR we received last quarter, the crude oil example that I already told you, and even things that I can't imagine and that are suitable to be, let's say, automatically read, automatically indexed, and then to calculate if it has anomalies or not. Sorry, I'm a little bit sick. So the goals is also to provide an application for non-technical users. So basically, the ones that explode this recovery into the invoices or documents were not technical users. So you have to provide them let's say, a visual tool. Then create a search tool that is able to make search to find finally what is the invoice. So based on different filters, like you see here. And then another topic is that for NLP models, you know that we have different languages in Switzerland. So differentiate by language and by this other challenge. So, okay, this is the goals that we want to arrive. So basically what we are thinking is in an application like this where you can open the invoice, see what is the kind of anomalies it has, the amount of anomalies and so on. But behind we will find some challenge that are need to solve to achieve this goal. So first one is extract text from this kind of documents. So as we'll see later, there are some different techniques, but if you are thinking of regular OCR, I can tell you that this doesn't work. Then detect the languages of the different invoices. Of course, to find anomalies using NLP. Then create a tool for search over these documents and to generate finally this one. And then a topic that is really trendy right now, that is the MLOps and the life cycle of the models. So let's see how we solve this main challenge. So we start from this one, and each of those topics it's solved by one services or let's say or custom code. So for the first one, this is a service form recognizer that we will test it later in the demo, that is able to extract any information from the invoice in this case. Also, it has different ways of work for different kind of documents, but it's slightly different than an OCR because it provides you, let's say, an extractor document. So for example, this one, it will know automatically that this is the person build to zip to. It will create let's say a structured format where you can see that for this specific item, the unit price is this one and the amount is this one. Okay. Then detect the languages. This is done by text analytics. Text analytics, we'll see that is let's say a cognitive services. So there are pre-trained models that serve to a common function. We'll see later. Then to create an NLP custom model, so this is code for you to understand that that matches these concepts to the ones that are not covered by the company in this case. And finally, how to search over the extracted content of the invoice plus all the models that we have created before is with a tool that is cognitive search. And then how to control the life cycle of the model is done with Azure DevOps, and it's called the technology. It's called MLOps. So let's go deeper into this one. So let's say this is the first one, how to extract text from documents. This is done by using, like I said, form recognizer. And let's say that the goal is not to extract the plain text of the images like in a regular OCR. The goal is to be able to, let's say, have a kind of order and a kind of relationship between these documents. So for example, like we are seeing here, it is possible to transform a table into an structured table that you can index. So with this one, we will have, let's say, passed from a structured document to unstructured, sorry, from unstructured document to unstructured document. So after this one, we'll have, let's say, for example, a table with quantity, description, unit price, and amount. And this is really powerful because for our next steps, it is possible. So here we can see an example of, well, a fake example of what we created. But for example, check the way it returns the knowledge. So here is the plain text of one row, but you can even filter by amount, description, quantity, unit. And this is also interesting for us because thanks to this amount, for example, we are able to see if the anomaly, for example, is 50 cents, or maybe it's even better to not price an alert, or it's 600, where you can recover. So then, with this in mind, we have to detect the languages. And why we have to detect the language? Because for the AI model that we will create later, it's something that is mandatory, because normally the models, well, there are some of models that are multilingual, but normally the models works better if they are specialists in some language. So with this tool that is called text analytics, we can extract the language. And what is this text analytics inside cognitive services? Well, Microsoft finally has some pre-trained models, but of course, a pre-trained model can serve for lots of things, you know. So these cognitive services models are mainly generalistic models. And what I say generalistic, what I mean. So for example, imagine that the tasks that are common from different projects. So for example, in terms of image, so detect persons, detect objects. In terms of text, calculate the sentiment, obtain the key phrases, detect the languages, as in this case. So they are models that are designed especially for this for this task. And with this one, okay, please observe the pipeline. So first we extracted the text from the invoices, then we have the languages, and well, also this part, but it's less relevant, the entities and key phrases in the text, and then we arrive to the final anomaly. So for you to understand, I think with this car example, it's mainly easy. So this is the invoice items. So for example, transport, reparation, and administrative cost. And according to the company rules, administrative cost and transport is not covered. So we introduce both inputs to this anomaly detector that we'll see how it's created, but it's an AI model. And then the result is that this and this is not covered, so the anomalies is 200 euros, and it has anomalies in both categories, administrative cost and transportation. Of course, if it will be like this, it will be really easy. You don't need any AI model because administrative cost links perfect with administrative cost. But the point is that when sentence appear with a different way, you know. So imagine even, well, transportation or moving, for example. Well, I'm not going to make examples, but you can imagine that same concepts appear with different forms. So how we did it? Because yeah, as you can see here, we don't have any trained data set. We just have these invoices, and we can't train a model. So well, we did it using NLP pre-trained models. And what are these NLP pre-trained models? Are models that are able, well, let's say more than NLP, we're embedding pre-trained models. So these models can provide a vector for any word or sentence that you provide. And these vectors has some properties, so they are not created randomly. So basically, some of the interesting properties are the closer the more the closer the vectors are, the less distance between those vectors, the less the more similar meaning of the sentence or the words. And oh, sorry. And this is something common that we also do. So first, we take these generalistic NLP models that are trained typically over Wikipedia or a big source of text, and then we retrain it over a specific vocabulary. And this is really nice because it's like the person do, no? So for you learn how to speak, how to read, how to understand in a generalistic mode, and then you make it a specialist in one sector or one thing that is your business, for example. So this is like we did, and then we create a validation dataset. So this is impossible to skip. So well, this is a little bit tedious, but it's necessary to see if the model is really working well or not. And then how we did with this model? Well, we encode. So we encode means generate the vectors of the non-covered items provided by the company and the items coming from the invoice. So also, well, we encode some synonyms of if each non-covered item to let's say to have more spectrum of sentences. And finally, we set the threshold, so meaning that if two vectors are similar by 89%, is anomaly or not. Oh, sorry. Then it's just to set the threshold, like I was saying, and can mark it if it's anomaly. So, as a result of this model, all the models were tested. Well, when I say all the models, I say the models for French, German, and Italian were tested on this validation dataset, and we achieved really impressive results with an accuracy of more than 90% in the 3 languages. And I recall that is the one that is most interesting for us, of more 90% in the 3 languages. So meaning that we can detect something that is not an anomaly, but we are sure that 99% of anomalies we are taking. So very good. So some information about those models. We created 3 models, like I said, 1 per language. Each model is more than 3 gigabytes, and it has 1 million of words inside. So just to make you an idea that this is not a joke, so these models are really weighing something. So okay, so recap, first we extract the text, then we find the language, then we pass it into these AI models, and what we need now is to provide this search tool where it's possible to make search and to, let's say, have indexed all the structured information we extracted from the invoice. And like I was saying, this is done with a cognitive search. Sorry, they recently changed the name from Azure search to cognitive search. So basically, the way of work is like you see here. So it applies all, well, in this case are these ones, but all the things that you said. So language detection, for recognizer, custom models that is possible also to a big set of to the whole set of documents, and you create a pipeline that is executed for each new one. So when is executed, all those information is indexed into an index that you can search. So meaning that you pass right now from unstructured to structured. And then, and to finalize, it is possible to make search with a great performance, by the way, in this index and to find some information. So for example, in the cases we have seen, just with this tool, it is possible to bring, let's say, really value to the to your job. Imagine that, for example, you have lots of unstructured documents, and just to extracting the text and index here and create the capabilities to search, it's something really impressive and a step forward in your strategy. So, well, with this step, we would finish more or less the project, but not really, because to put models and AI into production, we will need to do the MLOps part. So, well, I won't be deeper. If you have any doubts, please contact me, because it's something like really interesting. So basically, the DevOps part, and now I'm talking about regular DevOps. The goal of the DevOps part is to automatize the things that has to be done each time you create new code or you do something. So, for example, when you are creating a web page, there are you have your new feature of this web page, and then what you have to let's say deploy this new web page. So these steps are always the same, and here occurs the same with data scientists. So when you have more text, when you have, let's say, a new data set, a new model that you want to test, etc., you need to always do same steps. So the way of MLOps is to automatize those steps. So what are the steps to automatize? To train the model, to validate if the model is better or not, to deploy the model if it's better, and then to open this, monitor the model, and finally to come back. And this is like a cycle. So each time you have any information, it is a good practice to automatize this part. Oh, well, then we can see the proposed solution of this specific case. So this could be the architecture. So here, well, first check on this part that we have all the invoices, or in this case for auto, house, health invoices, and they are put into an Azure storage account. So cognitive search is, let's say, autonomous to have an storage account as input, and each new document on that one, it will detect it automatically. So next indexation, it will execute, and then we apply all the things that we have checked inside this cognitive search pipeline. So we start text on invoices, we enrich this information with language and with some entities, key phrases, and we apply the custom model to obtain the anomalies and to, let's say, to calculate these anomalies and to find which ones should be reviewed. So to obtain this NLP model, like I said, we are using Azure Machine Learning Services. This is the tool of Microsoft to train AI models. So when we finish, we put it into here. And then with this index, this is, let's say, the source of everything. Let's say we can do two things. First one is to analyze the statistics of this information using Azure Synapse and Power BI, and second one is to create the web app that we that it will be used by the documentation team to recover the money on those invoices. So Now, let's jump into a demonstration. So let me, well, like I said, it's impossible for me to show the regular rate, and as they are invoices, it's a little bit difficult. But I will try to show you the capabilities of each part separately. So first of all, we need to extract the text from the invoices, and this can be done by form recognizer. So, of course, we use it as code, but for example, let me to download. Well, this is very dummy. So, well, this one, for example. But form recognizer also have this way to work that is more visual. Let's say even you can retrain your model, and this was one of our ideas. But the result is that it works really good, as you can see here. So basically, and well, maybe it's easier if you see it like this, but it's impressive the number of information you can extract from an invoice with just applying that tool. And with form recognizer and cognitive search, forgot the AI, the custom models one. It's just impressive. So even the handwritten text is detected. So thanks to this tool, we are able to receive a JSON like this that contains the information all of the invoice, and even also the, well, it's a huge, like you can see. So even the position, but in this case, it's for us, it's just is just to obtain this part and this part. And well, also we indexed everything, because for the customer it is important to imagine that, for example, has emails, has invoice number, and so on. So this is something that is good to index. But check that, for example, with these tables, okay, check that it's really good. So it's possible. And well, of course, this one is really clear, so everyone can do it. But for all the invoices that we have checked, it was just awesome, because it was like a picture of a white paper that it was really crazy. So I think that tool is really powerful. If you have any doubt, you can ask me. But the way of work is just an API where you call with the document and it responds you all this information. Or let me. So column quantity, for example, column descriptions. So it's really impressive what you obtain with this one. So seeing this one, well, I won't test the language detection, because I hope you trust me, and this is something that is possible to do. And now, how to prove you that it is possible to obtain anomalies from invoices using AI. So, well, please don't, for those who are not common in Python, let me explain what this does. So with these two sentences, we are loading this model. This model in particular, it's in English. And then we have two methods to calculate the similarity of two vectors, so nothing else. And then what this vector can do. So this vector, like I said, it provides a codification for each sentence. So if we execute this one, we obtain that one. For example, if we create it, if we do it with this one, we obtain another vector. So Like I said, these vectors, that for us doesn't mean anything, has very interesting properties. So, for example, these sentences has a similarity of 63%, let's say. This one has a 71%. So they are, let's say, more closer. So the meaning, so the advantage of this warm embedding model is that understand the meaning. So, for example, bike and well, cyclomotor, it could be really close because they means something similar. So let's test, for example, and now is the real example. So imagine this an invoice with these items. So replace vehicle, substitution car, and here we have the claim items. Okay, so these ones are the ones that provided by the company, and these ones are the ones by present on the items, the claim, sorry. So we are able to find that each one represents the same. So more or less, I think it's clear. If you have any doubts, please ask, because well, this part is a little bit more hard than the others. Okay, well, at the end, if you want, we can open a little bit the dialogue. So finally, what we have created, and this is a final demo, it's this web page. So here, if I click and I won't do it, I will download the image. And what is the advantage of that one? That I can filter very quick, for example, the anomalies present on the invoices. So I'm filtering right now the anomalies amount that has more than 300. I can also filter by date. I can check what kind of uh, anomaly has the invoice. So with this one, it's really easy to recover. And we are also providing let's say a web page where a non-technical user, and this is important, can search and can find the invoices directly in a, let's say, visual format. So let me come back to the presentation. Finally, outcomes of the project. So, well, more than 50K invoices indexed per year, with a grand total of 200K invoices, and with any problem about the scalability or let's say performance in the indexation, because it's a microservices architecture based on Azure function that I didn't explain, but if you have doubts, I can explain to you what we did. So we are able to ingest this number per year with a recall on the detection rate of 99%. So basically, we are detecting everything, and we are finally recovering more than 2 millions per year. So I think this is the outcomes. I think, well, without doubt, this is the most successful project I've done, because yeah, normally when you do AI, you can measure the return of investment, and in this case, it's clear. So it has a rate of really crazy. The cost of the project slash this number of months, one of the most successful projects I ever did. So, what would be the next steps if you want, or if you find that that this could be interesting for you? So first of all, the prerequisites, where you have to, let's say, to estimate if it has an ROI for you. And here I'm not talking just about the ROI we just seen, because this is a very special case with invoices. So in this case, of course, yes. But even remember the number I saw at the beginning. So even save this 40K per worker, it could be interesting. So then if it matches your strategy and if you have the internal skills to do it, then analysis. So what are the objectives? Like I said, so I want to answer, sorry, this question, and this question. What would be the end user? So this also it's important, because, for example, for the, if you remember the architecture for the BI team, what the web that I just showed you, it's not important. But let's say if the end users are not non-technical, for example, you have to think how to do how to do it, and then the outcomes you want to obtain. Then to propose a roadmap, and here, and it's something that I think it's important, is to start to not start big. So, for example, in this specific case, we started doing it for just a car claims, and then we extended to all the claims on the company. But when you have your specific idea, you just run a pilot to see if it's interesting. And when we see the money we were recovering using this for cars, we directly decide to go for the whole one. And then deploy the solution, the knowledge transfer and adoption. This is also a challenge that you have to face, and also the continuous improvement. In that case, it's really easy because, well, we created the XML pipeline that help a lot in this part, but also, well, it's something to evaluate. Well, I think that's all. I hope you like it. It's a really complex project. And yeah, I hope you don't have doubts. If you have any, please ask me. This is my contact. I will send it by the chat, just in case doubt. And yep, if you have any doubts, please ask me, because yeah, it's a really really complex project. So maybe I can help you. Otherwise, you have my contact. So if we don't have any, just to say thank you. I've really enjoyed to explain this project, and thank you very much for joining us.